Wastewater Dan presents wastewater math calculated with Excel spreadsheets. As a new service of ESDLT's Environmental Academy, environmentalacademy.com, today's example, calculate pounds of primary effluent solids. Today's problem reads, the influent flow to a secondary treatment plant has a primary effluent of 4,791,667 GPH with 123 mg/L suspended solids. Calculate pounds per day of primary effluent solids. So this is a poundage calculation using the waste stream version of the formula. And the waste stream version requires 3 elements in the formula: a fixed element for the conversion factor from gallons to pounds, and 2 variable elements. In this case, the concentration goes in as parts per million or milligrams per liter from lab results, and the flow rate goes in million gallons per day, which means we have to show the gallons of water per day as flow and then convert it to increments of millions. Therefore, the concentration and the flow rate will be in the same time increment. So that's the basics in the formula. Let's look and see how we're going to insert this into our Excel spreadsheet. You can go to a blank spreadsheet. You can actually type in cell C1 the answer, which is pounds of primary effluent solids using milligrams per liter as the concentration. You can go to A1. You can format it as full numbers with commas for every thousands. You can make it bold and centered. And you can simply type in this formula in the formula bar. Now, before you type in the formula, though, let me just explain that the conversion factor is given to us as a conversion factor. The concentration is given to us as milligrams per liter. So both those numbers will go into the formula simply as given in the data in the problem. The flow rate, however, is given to us in hours. And so we're going to show in the formula the conversion factor from hours to days, and then gallons per day to milligrams per liter. So that will all be converted actually within the formula itself. So now let's go to the formula bar and let's type in this formula. Equal sign, 2 open parentheses, 4791667, close parenthesis, multiplication key, 24 division key, 1 million, close parentheses, multiplication key, open parenthesis, 123, close parenthesis, multiplication key, open parenthesis, 8.34, close parenthesis, and then press return or enter, and you'll see in A1 is the answer of 117,969 pounds. Now, I've added a bonus to this video for those who want to see some additional information about poundage calculations. And for those who are satisfied with this part for your answer, then please subscribe to my channel and interact or participate by commenting or adding a question through my website, environmentalacademy.com. And I thank you for listening. For those who want additional information, the bonus includes modifying the concentration to a percent and inserting the formula in the percent solution version formula. So that's going to be today's bonus. So the first thing we want to do is we want to slide on down to the bottom of the spreadsheet and look at the bottom formula. And the first thing we're going to do is we're going to take the milligrams per liter and we're going to express it as a percent. Just take milligrams per liter, divide by 10,000, and that's going to be a percent. So 123 milligrams per liter is the same as 0.0123%. So that's the first thing. The second thing is that if we have a percent as the concentration, then that changes the way we insert the information into the formula for poundage calculation. Okay, so if you look at this second formula here, and if you go to go to row 3, and in C3, if you type in pounds of solids as with a percent, and then we're going to use a percent of 0.0123, which is what we calculated below. So now what we have is we have the same basic formula that we had above, except the 1 million is not included in the gallons. Instead, it's included in the conversion. So the formula for pounds of solids using the percent solution version has 3 elements. It has the conversion factor, it has the concentration, and it has the gallons. But the concentration, instead of it being mg/L, it's actually going to be the decimal equivalent of the percent. And so you take your percent and you divide it by 100. So that's where we have the 0.0123 divided by 100 in here in this second formula. And on the gallons, you put in just gallons. So we're going to have gallons per day. We're going to take the flow rate in a day, and we're just going to treat it as gallons per day, which is, and then convert it to increments of millions. So we're going to take our gallons per hour, we're going to multiply it by the 24, and then we're just going to show gallons. When you have a percent, you show your flow rate as gallons. So if you go to A3 and you type in this formula after formatting and its whole numbers with commas, and then coming in and making it bold and centered, for A3 you can go to the formula bar and you can type in this formula right here. You can put equal sign, 2 open parentheses, 4791667 close parentheses, multiplication key 24 close parentheses, multiplication key open parenthesis, 0.0123 division key 100 close parenthesis, multiplication key open parenthesis 8.34 close parenthesis, and then press enter or the return key and you get the same answer. So the bonus shows how to take the milligrams per liter, convert it to a percent by dividing by 10,000, and then taking that percent and putting it into the formula and moving it from a percent to a decimal by dividing by 100, and just do that within the formula. Now another way to do it, since we know that we're dividing by 10,000, which is 4 decimal points, to get the percent, and we know we're dividing by 100, or moving it 2 decimal points to get the decimal equivalent, a one-step process to go from milligrams per liter to the decimal equivalent of a percent is divide by a million. And that's moving the decimal point 6 places to the left. Now when you do that, you got to make sure you put your gallons of water in as gallons. So if you make both of those conversions, then you're going to end up with the same answer. So for all of you, I hope this video has been useful and helpful. Please subscribe to my YouTube channel, participate, interact by commenting or asking questions through my website, environmentalacademy.com. Come back often because I'll be publishing videos at least once weekly, and thank you for listening to this 10-minute video.